Okay, so let's let f of x equal e to the negative 1 over x. All right, so negative 1 over x is in the exponent. And there are three parts to this. So first, find all horizontal asymptotes, if any, right? There may not be any. Find all vertical asymptotes. At each vertical asymptote, find the one-sided limits. Okay. How do we start this problem? So part A, finding horizontal asymptotes. How do I go about finding the horizontal asymptotes of any function? What is the general strategy for any function? Limit. So something with a limit. So take limit, right? But you can't tell me what, I can just take the limit. Like, what does that mean? Take limit from each side? Each side of what? I don't understand what that means. Find the limit to infinity and minus infinity. I assume you meant to write and there. Right. Negative infinity limit and infinity. Take the limit using infinities. That's right. There are no sides. There's no such. I saw some people write this on the second exam or third exam. I forget when it was. Something about taking the limit as x approaches infinity from the left, infinity from the right. That doesn't make sense, right? There's no such thing as infinity from the left and infinity from the right, right? To take x going to infinity means that I consider arbitrarily large and positive values of x. There's no such thing as being on the left or right side of that. Negative infinity means arbitrarily large but negative values of x. Okay, so there's no such things as sides here. Okay, so we compute the limits at infinity. We compute the limits of f at infinity. So that's kind of the shortest way of saying that, but you know that that actually means we compute two limits, right? We compute the limit as x goes to negative infinity, and we compute the limit as x goes to positive infinity, right? There are two separate limits that we actually have to calculate here. Okay, so for negative infinity, I need to calculate the limit as x goes to negative infinity of e to the negative 1 over x. So can someone tell me what happens here? Can someone explain how to compute this limit? Or what do you think the next step might be? And we're also going to consider the positive infinity counterpart to this. Okay, yeah, direct substitution. I mean, that's essentially what I'm asking you to do. So what happens here? Can someone explain to me what happens as x goes to negative infinity? What are you looking for in this expression? What do you think happens here? Is it e to the 0 equals 1? I think you're right. Right? As x goes to negative infinity, what happens to negative 1 over x? Right? Just as like a little side comment here. X going to negative infinity of negative 1 over x, what is that? That's just 0, right? And the same thing down here for the x going to positive infinity. If x goes to positive infinity, negative 1 over x still goes to 0. Right? So in both of these limits, we actually see that the exponent goes to 0, so I just end up with e to the 0 equals 1 in both cases. So in other words, this function has exactly one horizontal asymptote at y equals 1. Okay. If there are any questions, please ask. If not, let's look at the part B. Find all vertical asymptotes. So again, the function that's at the top of the screen. So how might you go about finding the vertical asymptotes of this function? I mean, usually we set the denominator equal to 0, but I mean, this is one of those cases where there is no denominator, right? I mean, this function That's why I always kind of stress in class that vertical asymptotes have nothing to do with denominators. What do they have to do with? They more have to do with where a function might be undefined or become unbounded, right? Let's actually answer a different question. Maybe this will kind of help you figure out what the answer is. What is the domain of this function? So Damien said, he asked, is it minus infinity to infinity? Are all real numbers allowed to be substituted into this function? Is the domain of this function all real numbers? One to the infinity? So only numbers that are bigger than one can be substituted into this function. Is that true? Looks like some other people have an idea. Let's wait for them. Hmm. Maybe let's. We had a lot of problems with this yesterday when I was asking about domains. So maybe let's do a little poll. Since those are the only answers I have right now, I'll just include those. Did that poll actually go? Okay, well. Okay, so here's a new poll. Sorry about that. Okay, so start custom poll. What is the domain of this function? Okay, so for those who chose negative infinity to 1, union 1 to infinity, the second choice, can you explain why you chose that? It's the range? Actually, that's not the range, but at least you're getting closer to it. The range of this function cannot include negative numbers. The range is actually 0 to 1, union 1 to infinity. But that question's a lot harder than asking about the domain. If x equals 0, then the function is undefined. Yeah, I mean, I definitely can't substitute x equals 0 into this function. I mean, clearly, if you're including 0 in the domain, that's wrong. And if you're excluding 1, that doesn't really make sense. I mean, e to the negative 1 over 1, that's perfectly fine. That's just e to the negative 1. So do we want to maybe revise our answer to the domain? What is the domain of this function? It was actually none of the choices. Well, it was the disagree choice. None of the three choices I gave were actually the correct domain. Right, negative infinity to 0, union 0 to infinity. Right, 0 is the only number that's not in the domain. Now, where is this function continuous? So, the function, its domain is all real numbers except 0. Where on that domain is the function continuous? Are there any numbers in that domain where the function happens not to be continuous? How would you know that? Right? Negative 1 over x, we've discussed this before. Negative 1 over x is a rational function, right? It's a ratio of two polynomials. And we've learned that where is a rational function continuous? A rational function is continuous on its domain, right? So negative 1 over x is continuous everywhere except 0. Then when I compose that with the e to the x function, e to the x is continuous everywhere. So negative 1 over x is continuous everywhere except 0. E to the x is continuous everywhere. So when I compose them, I get a function that is continuous, again, everywhere except 0. So in fact, this function is continuous on its domain, right? Because e to the x and negative 1 over x are both continuous functions on their domain. Now, having said that, now let's try to use this for part B. If now you know that this function is continuous on the interval, on the set, I should say, negative infinity to 0, union 0 to infinity. That's where this function is continuous. Where is it possible for this function to have a vertical asymptote? It may not have a vertical asymptote there, but where can this function have a vertical asymptote, right? Only at 0, right? Because if it's continuous everywhere else, there can't be a vertical asymptote there, okay? So x equals 0 is the only possible vertical asymptote for f. And we will actually see in part C, it really is a vertical asymptote. So now let's talk about x equals 0. So find the vertical asymptote kind of means find the domain. No, it doesn't really. Remember, domain does not mean vertical asymptote. For instance, let's look at this function. Vertical asymptote at x equals 1. Right now, I have drawn this function. The domain of this function is negative infinity to 1, union 1 to infinity. But there's no reason why I had to do that. I can also just let's just fill in this dot right there. Let's put in the whole 1, 3, whatever. Now, what is the domain of this function? The domain of this function is all real numbers. So the domain of a function has nothing to do with where's the vertical asymptote. However, where the function is continuous does have to do with the vertical asymptote, right? Because the only places where you might have a vertical asymptote is where a function is not continuous. Okay. Could you also determine this by using ln to put it quotient form and find the VA like that? Well, the thing is, ln doesn't necessarily obey vertical asymptotes, right? For instance, the function just f of x equals x has no vertical asymptotes, but now if I take the ln of that, that does have a vertical asymptote at x equals 0. So taking the ln of a function does not preserve the vertical asymptotes, okay? So you cannot do that. These are good questions, right? I think they really touch on a lot of common mistakes, right? The domain of a function has nothing to do with the vertical asymptotes of the function. But where the function is continuous does. Okay. So part C. So now that I believe that x equals 0 is a vertical asymptote for my function, how would I go about verifying that? What is the condition for a vertical asymptote? How do you determine once and for all that's a vertical asymptote? Plug it in, you should get non-zero over 0. That usually works for most functions. But think about it. Think about this. What about ln of x? Right? That is a vertical asymptote at x equals 0. Right? Think about the graph. If I plug in 0 into this, I get ln of 0. Does that fit your model of non-zero number over 0? Not really, right? because this isn't a rational function. You are correct if I have a ratio of two functions and I get non-zero over zero, absolutely I have a vertical asymptote. But this function doesn't really fit that. Your limits should equal infinity or negative infinity. All right, good. So to be more precise, if x equals 0 is a vertical asymptote, the only surefire way to determine it, right, from the definition is that if I take the limit from the left or the right, one of those limits should be infinite, right? Okay, so let's actually do both of those. So let's do limit as x approaches 0 from the right of f of x. So this is limit as x approaches 0 from the right of e to the negative 1 over x. Now, it's probably going to be useful to go off to the side and do some scratch work, right? What happens to just the exponent? What happens as x approaches 0 from the right? What happens to negative 1 over x? It doesn't approach 0, right? If I do negative 1 over a very, very small number, like what Damien said, I'm going to get a very, very huge number, like negative 1 over 0.000001. That's huge, right? That's not close to 0. So the limit is not 0. So let's see. So what did Damien say? So Damien actually said, very good. He actually said negative 1 over 0 plus, right? Now we know that the limit has to be infinite, right? Because if I get negative 1 over 0, non-zero over 0 tells me the limit is infinite. So it's definitely infinity. The numerator is negative 1, and the denominator is positive, right? Because it's approaching 0 from the right side. So negative over positive gives me negative infinity, not positive infinity. This gives me negative infinity. But keep in mind what's happening here, right? As x goes to 0 from the right side, negative 1 over x, that goes to negative infinity. So now I'm essentially looking at e to the negative infinity. So now can we go off to the side and do another piece of scratch work? What happens? So let's use a different letter, not x. Let's say u. What happens as u goes to negative infinity of e to the u? Because I want to know what happens to the expression e to the negative infinity. Here, we can draw some graphs here if it helps. All right, here's net y equals negative 1 over x. And y equals e to the u. Looks like this. So what can you say here? So it approaches, so u is not equivalent to 1 here, not equivalent to 1. As u goes to negative infinity, if we're looking at this graph, we go all the way to the left, and we can see that this just goes down to 0. So this gives me a limit of 0. So now putting this all together, if I go back to the original limit, right, this essentially looks like e to the negative infinity, which we now have determined is actually just 0. Right? E to the negative infinity is the same thing as 0 according to this limit. So this limit here is 0. Excuse me. So actually, so far, have we determined whether x equals 0 is a vertical asymptote? So far, it doesn't look like it is, right? Because from the right, I get a limit of 0. But now let's look at what happens from the left. Okay, so sort of the same idea, right? Let's go off to the side. Let's look at just the exponent first. But now x is approaching 0 from the left side. We're going to use the same graphs here. So can you now tell me what is this limit as x approaches 0 from the left side? What do I get? So what is this limit here? Positive infinity. That's right. Right. I know it's infinity because it's non-zero over 0, but the top is -1 and the bottom is negative. So overall, I get positive infinity. So now I'm essentially plugging in positive infinity instead of e to the -1 over x. This looks like e to the infinity. And what is e to the infinity? So formally, that means the same thing as saying limit as u goes to infinity, e to the u. And what happens according to this graph as u goes to infinity? What happens to e to the u? What is the value of this limit? It's not 0. As u goes to infinity, we're actually going towards the right. And what happens to all these y coordinates as I go to the right? They get larger and larger. They get arbitrarily large, right? So they go to positive infinity. So that means this limit here is positive infinity. Right? Again, because this limit we determined, since the exponent goes to infinity, this looks like e to infinity, and e to infinity is just infinity. So what would you conclude? Is x equals 0 a vertical asymptote of this function? Yes, because the left-hand limit is infinity. All right. It doesn't matter that the right-hand limit is 0. So x equals 0 is a vertical asymptote of f since the left limit at 0 is infinite. You don't need both to be infinite. You only need one of them to be infinite. Right. And what does that mean the graph of this looks like? Just from what we have determined. Right. I know that there's a horizontal asymptote at y equals 1. Right. That we got from part A. From the left-hand side, it goes off to infinity. And from the right-hand side, it goes to 0. But remember, 0 is not in the domain, so there's actually an open hole there. So the function actually, the graph looks something like this. It's actually a very kind of funky looking graph. Right? So we don't often see problems like this or functions like this that kind of cooked up to make sure you understand the definitions, right? But functions like this actually do occur in practice.